Designing and validating robot material handling cells can be challenging, as it requires selecting the right gripper, which comes in various shapes and sizes. Commercially available grippers, for the most part, are only available in a static CAD model from the supplier. This means that to validate your robot cycle time fully, you need to incorporate the mechanical kinematic movements of the gripper. In this tech tip, you will learn how to build any kinematic gripper using SOLIDWORKS Robot Programmer Standard or Professional. We will start with a simple gripper saved from SOLIDWORKS and opened in the Robot Programmer Essential app. The first step is to change the travel limit preference. To do this, open the Preferences and navigate to the Manufacturing Simulation Apps Common Services section, located under Digital Manufacturing App Common Services in the Simulation section. Here we will collapse all and look for device analysis, and set the travel limit to interrupt. The second step is to define the kinematic joints. We will exit the 3D simulation environment by clicking Exit 3D Simulation on the toolbar. We will need to know the distance between the two jaws to set the jaw opening correctly. We can do this from the Measure command in the Tools section of the toolbar. Select each of the two jaws, and you will have the minimum distance. In this case, 210 millimeters. Now it is time to define the kinematic model by launching the Define Kinematics command from the Kinematics section in the toolbar. Please note that the command is modal and will stay active until you exit. We select the base of the gripper and then the fixed joint icon from the pop-up window. After this, we select the first jaw, then the prismatic joint icon from the pop-up, and again the base as the parent. From the following pop-up, select the positive x-axis for the joint movement and command joint as the type of joint. Next, we select the other jaw and again the prismatic joint icon from the pop-up, and again the base as the parent, and selects the positive x-axis for the joint movement and non-command joint as the type of joint. Finally, we exit the Define Kinematics command by clicking it on the toolbar. Now, we need to define the behavior, which can be done from the Motion Controller tab in the toolbar. We click on the Define Mechanical Resource command to define the attributes for the mechanical part of the gripper. From the Resource Type dropdown, select Tool Equipment, then click OK, and then select the simple gripper from the tree. This brings up the pop-up window with various commands. We will click on the Travel Limits icon and set the travel limits to be between 0 and 105, which is half of 210, and then click OK. The last step is to add the kinematic relation between the two jaws. We click on the Kinematic Relation command from the toolbar dropdown and select the simple gripper from the tree. This brings up the Kinematic Relation window. Here we select the Prismatic 3 non-command joint and then click the Add Edit Relation button to bring up the Define Joint Kinematic Relation window. Here, we click the Degree of Freedom Dictionary and then double-click on the DOF1 member to bring it into focus. Now, we add a minus sign in front and click OK. This will make the second jaw move backward toward the first jaw. Now we can return to the Define Mechanical Resource command to test the kinematic movement. Click on the jog icon from the pop-up toolbar, and then use the triangular icon to scroll back and forth between the travel limits of the jaws.